support vector machine or decision tree that are also classification models, which we'll see some of them. If you wanted to check whether a student will pass an exam or fail, last time we were calculating what will be the student score, right? But if you wanted to see whether the student will pass or fail, then machine learning algorithm will be more, logistic regression will be more ideal. If you go back and check, you discover that many a times when you have your emails, we have different folders, and there is a folder there called spam. The idea is that if people send you unsolicited emails, just random emails, they are not people in your contact, the system should be able to identify that this email is just people spamming your inbox, and it should automatically be classified under the spam folder, right? And if you have taken note of that, one thing you will also discover is that there are moments that somebody sends you a legit email, an email that is coming, focusing, or the person sending to you, that the system will mistakenly send it under spam. Yeah, so in that case, that is a classification error, or that brings up the issue of accuracy of our models, which will take time today to look at how we can verify the accuracy of a model as we did with the previous one. And so it becomes very, very important for us to always try to know how accurate is the model that we have constructed. So we'll see the various things. Now, in a machine learning algorithm, one of the things we said is that you always need to know which, especially for classification, you need to know what is your outcome variable and what are or is the input variable, right? Outcome variables, we are referring to dependent variable. Input variable, we are discussing what? Independent variables. It can be one or it can be multiples. So we'll normally call them as X, as we'll see. And the idea with machine learning or with logistic regression, as I think that we have not done it before, is that it takes inputs and map them to the output using what we call the maximum likelihood. The maximum likelihood. And the concept of the maximum likelihood is that it relies a lot on probability.
Recording in progress.
It relies a lot on probability by trying to check and see if what is the likelihood probability that you will fail an exams, right? We are trying to check whether you fail an exams. What do? We calculate your probability. And what we know is the probability range between what? Always between 0 and 1. So if probability range between 0 and 1, then we know that it's like in exams. If exam is on 20, we know that by default the pass mark should be what? 10, right? And the same procedure, what happens with this classification model is that when they pick up an item, where you pass an exam or fail an exams, they calculate the probability that you pass an exam based on the input feature that will be added, right? And if your probability is above 0.5, then there's high probability that you pass an exams. So it can be 0.5, 0.6, 0.7, 0.8, maybe 0.9. If it is 1, it means it's certain that you pass an exam, right? Because there's a certainty. When probability is 1, it means there is 100% confidence that will happen. Now, if it is below 0.5, then we are doubting. That is the same basic logic that is used when we are trying to use this classification. And there is what we call the sigmoid curve, which is the idea behind the sigmoid curve is that it is a function that converts our negative, because generally we have the odds of, when we talk about odds, especially for those who did medical sciences, what's the odds that this thing will succeed or fail? We normally use the odds, and for odds, the odds can be 10, which means If you say the odds of passing for somebody is 5, means the person have maybe 5 times higher chance of passing compared maybe to others, right? And so odds range between maybe 0 to infinity. 0 to infinity. So the small curve converts the values between that 0 to infinity to the range of, I mean between negative infinity and positive infinity to a range of value between 0 and 1. So it should be probabilistic in nature. So we'll see the curve as we make progress, how that is done. And with that, it maps the probability now based on the functions that we are getting. That's why we call it the semi function, which we'll see is like an S shape. Remember when we were doing normality, we say we have the U shape. The bell shape curve. So, but for classification, we have the what? A semi S shape. Yes, we'll see example at the end of all this. So, now the reason why we use logistic regression. Logic is one of the most highly utilized machine learning algorithms. That's one thing you need to take note of. It's highly utilized. We have others. We have logistic regression and random forest. The reason why they're highly utilized is that at least it has high probability of giving us more accurate results, and it is easy. It's much easier to implement compared to others, and also simple. It's easy and simple to implement and fast in getting us the results. There are others that may take a long procedure to get our and so we can also have our coefficients. Yes, we have our coefficients. We were doing with whether it was SPSS or we talk about coefficients, which coefficients gives you now the probability. And what happens under logistic regression, which we will see, is that it has the probability to give us which factors will play a major role on determining whether something is classified in a particular group. Yes, for instance, if we are talking about what influences the value of a rent or the house, we know that location is a factor. But what about the nature of the house, whether it's block house, tile house, and we will play the location and maybe let's say the nature of the house, whether it's thatch house, floors, or bungalow, and the rest. What are those funny names like that? Will play a role, right? More than location. Because if a house is in a bush and it is kind of block, it will still be relatively more expensive than. So distance may be a factor, but the nature of the house may play a major role more than distance, and maybe other factors. So logistic regression can basically give a weight to our factors, and with the weight, we're able to now get more accurate results. Now, it also gives us a range of statistical techniques that we can use for evaluating our model. We'll talk about confusion matrix. We talk about the accuracy, precision, sensitivity, and many others, which are all techniques that we use to test for accuracy.
Recording in progress.
To test for accuracy of our model. So, that being said, any question? Any question? Any question? So I've shared the model that we have to cover, which is we'll still use a data set that we used before, and we'll use the Titanic data set. We have used it when we are doing basic regression. No, when we are doing how to analyze data. Cleaning, data cleaning. We use it under data cleaning. Yes, so we have it here again. And so the idea is that at the end of the day, we should be able to explore our data, understand the data set. Then we should also be able to clean our data set, and we should be able to evaluate the accuracy of our model. And so, that being said, let's understand the concept of predicting. Now, when you make predictions, when you make predictions, the first thing you need to understand is that anytime you make predictions, there are 4 possible outcomes. I think we have said this before. There are 4 possible outcomes. The first outcome, we may call it true positives. And true positives says that let's use a scenario to put it. Let's say you want to predict whether the student will pass an exam, so the student will fail. So the 2 outcomes by default is pass, and the other one is fail. Now, for the concept of true, how do I get the result? Give me a second. So, for true positives, let's say this is when we predict that the person will pass and the person passes, right? True positive. So true positive, let's say true positive TP, we say the person will pass and the person passes the exam. So that was our prediction. So we make correct predictions. Now, the next possibility is true negative. We predict that the person will fail and the person fails, right? So that's true negative. Now, we have false positive. False positive, we predict that the person will pass. False positive, we predict that the person fails, but our model says the person has passed. Right? The person fails, but the model says what? The person has passed. So we say fails, but predicted as passed. So the person fails, or we're using the person failed, but we predict that the system predicted that the person passed. And the last option is a concept of true negative or false negative, which is basically the opposite of what? False positive. Right? The person passes, but the system says that the person fails, or the person failed. That's the idea behind our prediction. So anytime we're doing predictions, we have that 4 possibilities, and the idea is that we should be able to know and we use this to judge the accuracy of our model. So by implication, we see what we have. Now, why do we want to understand this concept of true positive and negative or false negatives and the rest? The first thing is that it helps us to evaluate our models. And so in evaluating our model or the algorithm, we use the concept of true positive and the rest. We have accuracy, which is the total number of true positives plus true negatives divided by the sum totals of the possibilities. So if we had, let's assume that we had about 100 as a total score, we have true positive to be 30. Let's just say true positive equals to 30, and true negative maybe 20. Then our accuracy will be what? 50 on 100. Our accuracy will be 50 on 100, right? Do you get that? Accuracy, total number of true positive plus true negatives divided by what? The total model, or the total whether the sample size or options that we have. Then precision is the total number of true positive over what? True positive and false positive. It measures what? How relevant is our overall model. So precision now will be 30. In this case, let's just say it should be 30 over what? It should be 30 on 30 on 50. Remember, we had true positive to be 30, true negative to be what? Wait. Am I reversing it? No. Okay, this is false negative. Then false positive. Let's give false positive to be 25. And the last one now is what? True. The last one is true negative. Have we used true negative? This is, let me remove this from here. This true positive, true negative, false positive equals to this. This should be 75 altogether, right? So the last one now should be what? False negative, which should be, I think, 25 also, to give us 100. 100. So all of that should give us 100. So now accuracy here will be the same as, let's look at our accuracy from a manual perspective. So when you are going down, is the same as true positive plus true negative. That means we have 50 over the whole model, which is 100. So it's about 0.5%. 0.5, right? Yes, or 50%. If you put it in, which is the same as 50%. If you are putting in terms of percentages. Then precision, we say it is the same as true positive all on true positive plus true negative, which should be now our true positive is 30, true negative is 25. So it should be 30 over 55. Abi? 0.5. 0.55, right? Something like that. Yes, which is 55.5%, I think. This thing is telling us, which is the same as 55%. Then let's look at the recall or sensitivity. It's the same as true positive over true positive plus false negative. That should be the same as what? That's 30 plus 25, right? False negative. Is 55 also? Let's just say 30 divided by 55, which is the same as, it's also 55%. Oops. This thing keeps stepping us. So sensitivity or specificity, true negative over
recording in progress.
True negative plus false negative. That should be true negative is true negative. Where's true negative is 20 plus 25. So true negative is what? True negative was 20 divided by 45. And F1's score is basically the harmonic 44.4%. So F1 score is the harmonic mean of our precision and recall. Precision and recall, we use it to get. So we've not talked about harmonic mean. When it comes to a mean, we have different types: geometric mean, arithmetic mean, and harmonic mean. There are other types of mean. So, but we will see how. Now, we are doing this to understand the concept of how to evaluate the accuracy of our. So we can use accuracy, we can use precision, we can use recall. So anytime you hear they talk about what is the recall of your model or the sensitivity of your model or the specificity of your model, you should understand that they're asking for this. And it's common with classification or classifiers, right? Yeah, so I think we have already given an example from the general explanation where we talk about predicting pass or not. And in this scenario, the one that I have here is talking about maybe somebody will survive. So the person did not survive, the person survived, and so on and so forth. Should be able to. Now, there is something we often have when we are dealing with a model, and the model should always, a good model will have a best value. For those who have worked with NGOs, before they go out to implement an intervention, they always try to establish what we call the baseline model, which is what is the standard. It's like the standard, right? So how do we evaluate our success? For us to evaluate our success, we need to know the current state of affairs, right? We need to know the current state of affairs. If you know that somebody's standard of living has improved as a result of what you have done, you need to know the situation when there was not that intervention. So we need to establish a baseline model. Again, to establish a baseline model, we can basically say it is 1 minus the predicting variable minus the mean. But then this is just something that we might not really go into. And in our scenario, we are like saying we know that if an accident happened, then the situation that we expect, which is like the null hypothesis, if you want to put it that way, is that everybody died in that scenario, right? Yes, that should be the baseline. So to evaluate now, we'll take our baseline and compare. So if not everybody died, then who are those who survived and what influenced their survival? That's the question we're asking. But we always have that baseline concept, which is now, it's a little bit advanced concept, but it is important for us to understand that. For us to check whether there's a change or any improvement, we always have a baseline, right? Yes, we always have a baseline. And so, once you get your data, the next important thing is that, as for somebody who was not in our class, in the previous class, is that we have the concept of training. Now, if your model may need to perform well, it must go through training. There's a training process that the model needs to undertake, right? And we gave an example. Let's assume that we're teaching. You want to teach people, and so before you come and give an exam, you need to teach. So the teaching process is like training. So machine learning uses, or data science uses, that's the concept of training. I say, okay, if we need to ask whether you should be able to identify whether this person will fail or pass, at least you should study the profiles of all the people that are there, or some of the people that are in that class that have gone through the process, so you understand what are their features, so that anytime you bring somebody now, you look into it and be able to say, okay, based on what I've studied and understood about this data, or since I participated in this class and I will be able to pass the exams. That's the concept, right? So there's a training process. And the way training is done is that basically you have to, first, before you train, what happens is that you normally train with your entire data, your whole class, right? You just come and teach everybody. But in control settings, for us to really judge the efficiency of what we have done, we'll train some people and we'll reserve some persons that we have not trained, right? So it's like we're sharing, we're creating different groups of people. Some people will not go through the exercise, some will go through the exercise. Then after training, we'll bring everybody together and do a test. So we say, okay, we separated some people and trained them, some were not trained. After we're done with the training, we bring an exam now and put everybody. Thereafter, we'll assess those who went through the training, their performance, compared to those who did not go through the training, their performance, and see if there's any significant difference or they're the same. And so the exam now is a testing process in machine learning. So you have to come and test and evaluate. Now, but the way testing is done in machine learning is that we know the right answers, right? But we ask the machine to also predict and if they will get the right answers. So from that prediction, it goes back to what we have just seen. They will be true, positives. They will predict that this person passed the exams, why the person passed. They will predict this person passed the exam, why the person failed. They will predict this person did not pass, why the person did not pass, which is and so on and so forth. That is the concept. Now, that concept, we explain it in our previous class, just to bring it up again. Another concept to take note is the concept of standardization of our data and data transformation, which is a core aspect. Now, machine learning models work with numeric values only. Yes, generally, especially when we talk about supervised machine learning, they will do well with numbers. And so what happens is that if you are dealing with numbers, you need to do what we call to transform from, letters or strings or objects. You need to transform them. And there is a machine learning model called or library called one-hot encoding or encoder. With one-hot encoding, the concept is that we want to transform all our strings into numeric values. And looking at our data set, which the example we're giving, we have a variable here. Let's say the variable basically is embark, which is one of the variables we'll see. And so we'll not be dealing with embark here, embark S, which are different categories, right? So we classify, or let's say in terms of class, there are people in class A, there are people in class B, and people in class C. So we have different classes, but machine learning will not understand what we mean by a class. We don't understand class A, class B, class this. And so what we have to do is that we need to convert these classes into numeric. And to convert into numeric, one encoder, what it does is that it creates what we call dummy variables. Or dummy variables, or I don't know how, but that's how they call it, dummy variables. There is what we used to say, what for dummies. But the concept here is that each of those categories will become more or less a variable on its own. So, the class of, let's say the class of class 1, class 2 become variables where we have 0, 1, 0, 1, which stands for what? If somebody takes 1, it means you are in class 1, right? If 0 means we are not in that class. So that's the concept of converting now into that, in that kind of matrix. And once that is done, we'll now come up with different new additional variables that were not initially in our data set, such that at the end of the day, we discover our data set will have more variables than before. That's the concept of encoding that we should understand. Now, we have already talked about inputs and output factors. We need to identify which one is our dependent variable and which are our independent variables. So, in machine learning, or data science, most often we talk about features. Features are inputs, most often inputs, or inputs or independent variables. So we'll talk about we need to identify our inputs. And once that has been done, we can go ahead and start building our model. So, any questions so far? The process of building models normally starts from what? Importing our libraries. The first step is just for us to import our libraries, right? What's happening? Tired? So we import our libraries. And which are the libraries we need? And our libraries and our models that we need. So normally, you often see that we import our pandas, right? We import our NumPy. We saw NumPy. We import our Seaborn, which is for data visualization. We import our Matplot, which is for plotting also. Then our model selection or training. So we said we import from sklearn. So our main library that we're dealing with is sklearn, and sklearn has different sub models. So we'll go and choose the one that we need because that's what is needed for us. And here we're importing what? Train, test, split. What is this role? It helps us to divide our data into a training data set and into what? A testing data set. So we have two different data. The training is the one that will it's like you normally come to class and you teach and then you give mock exams, right? Yes, that mock exam is for people to, then you have the final exams where you come and evaluate. So that's the concept. Then which model are we dealing with? We are dealing with logistic regression. So we import our logistic regression. Remember, logistic regression is capital L, capital R. Import logistic regression. So from sklearn.linear model. So logistic regression is also what? It's one of the it's not linear. It's not. Yeah, it's still based to an extent on a concept of linear linear regression, but a little bit different, right? So we import logistic regression. Then we import now our from sklearn we enter dot matrix. These are what different tools that we use for evaluating the accuracy. So we have accuracy score, which we have already discussed before. We have confession matrix. We'll see what it is. It's exactly what we have discussed, but in a form of a quadrant. Then we have the confession matrix display, which is just visualizing it. Then this is for data plotting or for data visualization. And so we say that they should use a particular styling. Our style should be white grid. And so this is from SNS. Cbon SNS.set styling equals to white grid. So these are the things that we need to import as this particular machine learning model is concerned. It is the first thing. Now we have to use the Titanic data set. Now if you have the data set we upload, or we load the data set from SNS. So we said SNS comes with some data sets loaded data sets, which is the Cbon comes with this, and to do that we just give we need to know the name of the data set Titanic, and we use our loader function. So load SNS dot load data set, we pass the data set name. Right now we normally preview our data.head to see if the data has loaded successfully. So it's have Titanic. Same as could have put by what? DF here, right? I know we have been very used with DF. Right? So madam. So we can still put by DF here. It will still give us the same results, right? But let's maintain what was there for the sake of Titanic. So we maintain our Titanic. So we have our Titanic. And so what are the variables that we have? Looking at the data set, this is our index, the numbering. Python automatically numbers your cases, or this starting from 0. That's why it starts from 0. So if you look the first one at position 1, which Python will call 0, so did not survive, because 0 stands for the person did not survive, right? Was in class 3, right? Classes are converted in terms of class 1, class 3. Was a male, age 22, had one sibling. This parent, I've forgotten what this stands for, but there was no, I think, parent that I'll need to check this. Then paid $7, and the embark was S. Third class was in third class. Then who was the person with? The who here stands for where are you with? Was man. Or still, I see my still pointing back to gender. You see.
Sorry, friend, I don't do the class.
Yeah, it's okay. You're welcome. So we have adult, true or false. We have deck, embark, and the rest alive, yes or no, and alone. Those are just the variables that we have from the data set. Right? So we need to load our data, preview it to understand. Now, at least that's something we can again check in terms of what? get a detailed view of the data set, how many columns we have, how many booleans we have, how many this and that, data types. For instance, here we had 891 cases, right? And so range from 0 to 90, then there are 15 columns. That's just previewing the data. We check how many known zeros. For instance, age has 714 known zero values, and it's a float. We have different floats. Boolean is yes or no. Survival is not adding alone is a boolean, so you put it. So boolean, object. This one is category. Which one is category now? Category, okay, class, and so it goes. So this is the data set. We can take describe, and we say include all. Now, if you take describe, let's now check again. If we are on the data set, we take describe, and we say objects. So they will just look for the objects. Objects here, again, we say objects in Python means string, right? In pandas means string, because this is a panda. We're using pandas library there. So these are the variables that are string. For instance, gender is string, embark is string, who is string, and the rest. If we take describe, we say Titanic.describe, and we don't include anything within, then what we have is that all the non-object elements will be described, where we have the number of counts, the mean, the standard deviation, the minimum, the 25th percentile, the 50th percentile, 75th percentile, and the maximum. 50th percentile is the same as the mean, third quartile, first quartile, and the rest, min, max, and the rest. So again, these are just some kind of quick review of what we have seen. Once we're done with a preview to understand our data, then we can now go into what? Checking, data cleaning. So here should be the concept, idea about data cleaning. So data cleaning. Data cleaning. We have to clean the data. Because of data cleaning is very vital. So before we go into cleaning, we check for missing data. That's not an issue for us, right? So if you check now, Titanic is not the sum. Those items that have 0 means we don't have missing data. Those items with some numbers indicate that we have missing data. We can always convert that even as a fraction. So we do some basic data analysis. So basic data analysis, just to have an understanding of the data. We do some basic data visualization. And here we are using Seaborn to plot and matplot. So our interest here, our dependent variable or our outcome variable is survive. So we say sns.countplot, which is like frequency analysis. We say x is the value, the variable you want to that they should plot. So which means we could plot all the other values. For instance, let's plot SNS dot, let me just bring up the data set again. Titanic dot columns. So we could plot again let's say alone or alive, which is a variable in the data set. So I want to plot it we said that you put here alive. Now data is the same as Titanic, and the plot title should be, you can say frequency. What's happening? Here we want to say frequency of, I think, was it alive or alone? Pardon. No, not alone, but alive. Yes, it's not going. Alive. It's an integral part. Now, it's not like you must, when you're building a machine. Now, that's why, as a data scientist, you do more than just building models. You have to understand, analyze it. But if you're working in a big organization, there are people who do the cleaning and the analysis and just share with you data. Maybe a times already transformed for you to just go and build a model. So you don't have to go through the process of building whether this one has done that and that. But since you're a jack, you have to do your data visualization, right? So you can visualize the rest of the features. Here we have visualizing survivor as a factor of what? By gender. Compare. See that survivor was very low for male compared to female. So that's what we are noticing. You can plot the distribution of the data by age. And so the density curve. Data cleaning. So we are under data cleaning. So under data cleaning, we have to drop some columns, right? Not all the columns are we going to use, so we choose the ones that we have to drop. And again, the code is your data set dot drop, and you pass a list of all the variables you have to drop. This is a list, right? All this here is a list. We have embark town, alive, who, adult, male, class, and the rest. We consider them that they might not be useful now. We drop them. So since we're dropping columns, we always say axis equals to 1, and then in place equals to true. The concept of what did we say in place mean? What's the meaning of in place? Why do we put in place in that code? We are dropping within the entire data set. So we drop rows. We are dropping this first one handles columns. This one handle what? Missing data. The items that have missing data for Titanic dot embark. We say we drop the missing because there are just few. For age, we drop using median, right? And we check. So you can use mean or use median, but there are significant outliers in this age data. If you study, you discover there are so many outliers in the data set, so the median will be ideal. We know how to use outlier, right? To calculate or to check for outliers. I assume so. So now the next thing is converting. We've said machine learning focuses more on using numeric data, especially when we're talking about trained machine learning models, or supervised machine learning models. The logistic regression will not be able to. So we have to do converting. This part of data cleaning, converting categorical data into what? Numbers. So for machine learning to work better, you need to convert. And so we have Titanic. Gender was male and female, so we have to map it. Say gender, we should mention this. Again, either we put like this, or you come and put maybe comma in place equals to true. Engineer, have you discussed the program with tomorrow with Marinos? Deadline is Sunday, so we need to discuss how we handle the program tomorrow. So you can put in place equals to, so it will give you the same outcome. So for this, they're converting. We said they should convert. Female should be 0 and male should be 1. You could put any other values that you want. You don't have any intrinsic value. So one hot encoder, which we said we use it here, and so we say get dummies. Now we want to look at this data, this particular column here. Titanic. That. No, let me say not that. What is the variable name? Embark. Dot.
Embark had Q and C.
Yes, that's why I want us to check something. N unique. So if you check here, you discover that this is how to check for how many categories are there. There are 3 categories, right? So we use Titanic, this and that. And what are the categories? These are the categories: S, cure. We have C and cure, right? So these are the categories, and then missing data. Any stand for missing data in that embark variable. So what we do here is that with this pt.get dummies, the first thing is that they want to create now the different values, variables that we have. That's why if you come here, you see what they've done. We have embark cure, embark S, and they drop the first. Now they dropped the first. The first here was what? Let's say the first value was C. So you will not find C here because it's used as a reference group. Yeah, so we have only 2 categories, not 3. N unique and C. This one. It's N unique that we use. N unique is when you want to know how many of them are there. So it's 3. If you want to know this, take that one. And so we drop it and we create dummy variables such that if you come here, what you notice is that we have now gender or sex has 1, 2, 0, 1, 0, 1, 0 again. Class was already this, survive or this, embark, they have converted. Except this one alone. Why? Madam, you have errors. What's the issue? What's the error that you have? Issue. So, now if you go now.
So you were asking why alone is false and true.
Yes. Now, alone here, if you go back to when we are exploring this data set, you discover that that's when you become a data scientist matter. That's one. we said there was this variable was Boolean, right? So Boolean here is true or false. So when you take that education, they will ignore that. They don't treat it as what? As objects. So you need to do what? That's why there is this particular line of code that you need to add to it before it is taken care of, which is basically this one. So you say now Titanic alone, they should convert this as an integer. So automatically go to 0 and 1. So if you run now, you discover that they will alone now between 0 and 1. As type, that's when you want to force change the data type. We use this as type. Yeah, it's doing it. Get your outcome. Hey, how come I'm having class 3 this and that? I did not run my own code up here. Okay, maybe I did not run this one. Pardon? They have dropped this, they have dropped it. I did not drop the columns. So let me go back and drop. This is where column dropping took place. I did not drop my columns. So wait, my columns did not drop.
Drop column in data clean.
Drop column is part of data clean. Let me see. Let me load back my data and go down to this is what we have. Everything is okay. Data visualization and let's drop here. Drop successfully, right? Then this way we are transforming. Okay. And we map this one. Okay. That's good to go. So now selecting targets and features. We say features in machine learning will often be referring to inputs or independent variables or predictors, and target is the dependent variable. So we have to, now we are starting building them, we are almost building their model, we are almost there, and to do that we need to identify, so which are our X variables. So machine learning expect that you should specify your X and specify, or sklearn in particular, you should specify your X and your Y. So we say that in this data set, X consists sex, age, fair, siblings, patch, embark, cure, embark S. Now these are dummy variables created from the variable embark, and so we are using. Now the next step is the training and testing phase. You have to train and you have to test. So training. So before we go into training, we have to split our data into. So we saw in our last class X train, X test, Y train, Y test. This means that we have to separate our data into 4 different categories, or 2 categories. For X, for all the input features, we'll divide into 2. Those for training, and or let's say for all the input features, we'll select some cases for training and some for testing. And for the output or target variable, we'll select some features for training, and we'll keep some cases for training and some for testing. In which case here, we say X train X test, Y train is the same as we use this model. Train underscore test split into X, Y, and the test size is what? 80%. When you put 0.2, it means they should use 80% of the data for training and 20% for training. So if I put 2.5, it means I'm saying I use 75% of the data. Random state here, again, random state equals to 42. The concept behind random state equals to 42 says that you put this way you want to fix the model, because if you don't fix this model, as you train over and over, it will give you different values. It's not fixed. Are we safe? What's the issue? This is what I assign. Anything that matter. Your battery is going on. There's no anybody here would can use Dell charger, right? HP can do it Dell, but it may not install current. So what is the size? It's a small size. Oh. And then it has got it. It's your size. So most often in most of the models you see, random state is 42. I don't know why, but you can put any figure there, right? Yeah, is that you should. The reason is I want to fix the model. After 42 iterations, it should stop there and give you. So you expect to have the fixed score, not changing. And so once that is done, this code here is optional. You must not put this one, right? X the shape. Usually we want to check the shapes of the data set that you have created. It's optional. Yes. So if you put that, you simply just want to check. And so even without that, but if you check, you discover that we have altogether created 666 data has been reserved for training with 7 variables, and 223 has been reserved for testing, 7 variables. These are the variables 1, 2, 3, 4, 5, 6, 7 in our model. So the training proper. Now we get to the training proper. Model.logistic regression. We have to call our model. So which model? We create our model here. This is the model. Model equals to logistic regression, and then we fit our model with the data that we have reserved for training and test. So model.fit X train, Y train. Why? Because this is where you are doing the actual training. Again, we said training means you have to study and understand the data set, the properties, the features, the relationship, and everything. So this way we're doing the actual training, and if that goes on well, if you run it, you may have this error. You may have the error, you may not have the error. Now this error, if you look at this error, the error is that logistic regression has number of iterations that the model should run before it gives us an outcome. And the challenge is that by default it is at 100, and 100 may reach without you reaching the optimum or the optimal model. And so that's why we have this error. So to do that, we may need to adjust and say that they should increase. That's why we have this line of code. We say that go into to our model and increase this IBQ or this, which by default this number is 100, but you can increase it to maybe maximum iterations of what? 1000. If you receive this error, it means at this particular point the model has not reached the optimum performance level, but the limit that you set is like, say, okay, you should be able to iterate over 10 times. If you get the correct results you give me, but after iterating 10 times it hasn't, but you have said it should end at 10, right? So you have to increase that value. That's the essence of this code. Now this may not always be the case. It can work in your data set. You can bring in the same data set, it doesn't falls into this error or into this issue. So, but if you are working in any model and you receive this error, the maximum iteration reach, then you may need to add this line of code, which comes from this. You say make a pipeline, a standard scalar, and this should increase this. I don't. When you can make it, if you make it, there's no problem. But the issue most often, you should implement something when it's necessary. You get it? Know that the idea we're doing principles. Like I said, coding is not a problem. We're doing principles, right? So you understand the principle, and in time of need, you go get the model and use. Yes. Otherwise, you should not. You don't have to. So it's not like whatever we are doing, we are plotting and the rest. When you want to build a model, you need to plot. You must not plot, right? If you are building a model and data is already clean, you don't need to clean it. If you are cleaning data, we've not, for instance, cleaning, we do not check for outliers and the rest, but we have assumed. Is it important? It's important, but must we do it? We should do it if there is need. But it's good that you need to know that you need to clean your data, check for outliers, remove duplicates. We have not done that. But those are aspects of data cleaning. Now, once that has been done, we can now move on. The training has been done. After we run this code, and we can now go on to evaluate our model. So, at this point, this line of code is also optional. This line of code is optional. And what this line of code does is that we are telling that take my test results, right? Create a copy of it. Now, for the test results, we want to get the actual and the predicted and put them back in our data set so we can be able to evaluate the errors, right? So they say our error curve is that this is the predicted line here. We have the actual and we have the predicted, right? So the actual was 1, right? But the system predicted what? 0 for this particular case 804, right? It was I think 1 was a he, 0 was female, 1 was age 27, paid this amount, had no siblings, needs this, was embarked this, and the person 1 here stands for survive, right? So the person survived, but what we predicted there was that the person died. That's why I have 0 stands for die, did not survive, right? So this person survived, but our model is incorrectly predicting that the person died. If you want to put it in a sample, this and see the data. Having an issue. The value this does not match. Okay, let me see where the problem is coming from. Yes, string, yes, between, string, I have an error. Why predict is not defined? Which question? The work that I sent. This is a question for me. What is that I read? I don't understand. Where are we?
So this way. So when we're splitting,
Mm-hmm.
do you include why predict?
When we're splitting.
Mm-hmm.
No, you don't. There was no y predict in the model. There's y predict.
Y trade, X trade, comma,
Mm-hmm.
X test, comma, Y trade, comma, Y test.
That's all that's needed at that line of code.
Yeah.
You don't need to prove predict there.
Okay.
You don't need to prove
Where
predict.
do we need to define predict?
They say y predict is not defined. Are you using the new data set I gave you or the first one? Okay, let's go on and see. I'm not there. I'm still at this particular point. Do you have this correctly? This, do you have it correctly?
That's where there's an issue.
You have an issue.
Yes, make prediction and evaluate the model.
X test, y predict.
So the code for the baseline of
There's no y predict there.
running.
Yes, if not run, if not run it.
Yeah.
No, but even with that, I don't think that's where the problem.
You have to run the code before.
No, don't even.
library.
No, don't run that one. Don't run that one.
Yeah, okay.
Yes. Why is that your y predict is refusing? Guess why predict? You have the same error. No, but I say we should use the new one because that's the same problem I had when I was trying to work on the model. So I say use the new one because I understand that y predict. You are using the new one or the old one? If you are using the old one, I don't have that issue. Let me print. I have my predicted and this. Or run and are you using the new one? You say run this. Let me look for a cell that you should run first and see if the cell under coefficients. Run that one first. Let's see. Let me see where the problem is coming. After training, the next test, as we have said, is for you to evaluate the accuracy. And so there are different tests. So let's look at the report together. So 0.7. Yours is okay. Accuracy is 0.79. That's almost 80%, right? Yes, telling us that from the total data set that we have, for instance, how many was the, let's go back and check something here. Let's say now, we reserve 178 items, right? There's 178 items or cases were put forward testing. So take care of that numbers. 176. If you come here now, we said accuracy. What did we say accuracy was? The number of true positive plus true divided by the total score. And this is the value we have here. We have on this confession matrix, or this matrix here, what we have 91 plus 18. Take 91 plus 18, let's see. Was it 91 plus 18 or I make a mistake? So, true negatives are 91. These true negatives. Why is it so? Not necessary. You need to understand something. Get the principle. We have 0 and 1, right? And we have survive and not survive. You get it? So here, if we are having 91, this is like people who died, and we identify that people who died because people who survive, and our identifier survived. Then why it should be? Let me see. Let me see. Let me see. 91 accuracy is 70. This I expect this should be true negative, true positive. This is the first one is true positive, false negatives, then false negatives, these false negatives, these true negatives, then false negative, true positive. Madam, what's happening? It was not charging. I was not charging.
It doesn't charge it. Actually, true negative.
So, again, let's look at here. We are having zeros here. Precision is 83%. Recall 83%. F1 score 83. Why are they giving us the same? Because this and this, they're almost the same. Then precision for this is for the 0, precision for survive, precision for die, precision for survive. Then all together we add, it gives us this and this. This plus this will give us 106, right? Yeah. 91 plus 18. Then this one gives
109.
109. So that was supposed to come before this table now to see. So the question somebody asked, don't know who asked, was that why did the model make a mistake? Go and bring us answer. I don't also know. So at this particular point, not survive. This is its precision. This survive is 74%. And it's a factor of this. So another thing that is important. The next thing now, after doing this your model can end here with this accuracy. Yes, your model can end with this accuracy. If you want to deploy it, because if the accuracy is not the best, it's still, you need an accuracy of around 90, 95 and above will be more ideal.
In this case, we're not calculating mean error. Okay, because it's now
this classification, we are using different models to evaluate classification.
Mm-hmm.
Yeah.
One is not continuous variance. So we cannot calculate mean.
No, we don't calculate mean errors.
Yeah.
This and that. Mean error squared
Yeah.
or square error mean this and that. So, this particular line of code here just helps us to be able to know which factors play a major role, as we state at the start of the class, which we said. Now we are using this. We have already added this code, so here it was not that much necessary again. Then we pass the training, and they should be able to classify our and convert. Now the essence of this is just to convert into a table, which will have the table below. This is the table. And sort this line of code says we put them from the highest. So one of the highest things that contributed to whether you survive or die was the gender, followed by the amount that you paid, the number of siblings that were there, the age, then the cabin, and the rest. That's what the model is saying. Yes. So in a regression or in a logistic regression model, or even normal regression, you always have to get which factors are playing a major impact. Or in other terms, you could say which are the significant variables. And to get the significant variables here, we may need to, but this is logistic regression, so we may not, we may need to get their p-values to see which ones are like in that scenario, but that's not our interest here. So here was just to show us the Simoin curve. This is what we call Simoin curve I was explaining, which is basically converting our variables now in the form of a probability. Instead of having between negatives and this, we put it that range between 0 and 1. So the values now, so that the probabilities here. So the principle of Simoin curve is that values that have their probability above 0.5 are classified in the group, because using the principle of what maximum likelihood, where are you highly likely to fall? You may fall in the fail group, in the group. So when they study and see which of the groups you resemble, they will put you on the fact that you survive. That's the essence of this model. But you must not present it. It was just for class studies. But not that the logic behind is based on what? The sigmoid function, which is often used in logistic models. So now we have our confusion matrix. Confusion matrix is just a graphical representation of our values. How many did not survive? We are 91. That's what they're telling us, right? This one is this one is not survived. This should be, or not necessarily putting that way. This is our accuracy. True positives, true negatives, false positive and false negative, put in that way. Let me see whether I have a column here representing that. For instance, here, if you come here, right, 18 here says that if this survive, right, how many people were predicted that they survived that did not survive? You get it? This is what?
Okay.
18 persons were predicted that they survived. Why they did not survive?
Persons survived, but the prediction said that they did not survive.
Yes. So the prediction said they did not survive. Here, this survived. So altogether 95,
Yes.
55% survived, and the system predicted. So this is our true positive.
Yeah, that's a true positive.
This is a true positive here. So at least here is more explicit, right? Those who survive and the system predicted they survive. These are those who survive and the system said they did not survive. And now we see here that these are those who did not survive and system said they survive. And then whereas here, those who did not survive and the system said they did not survive. It comes back to the fact that forms our what? True negative. That we are trying to explain, we are doubting here. That this is our true, where is it again? So this is our true negative, right? This is our true positive, This is our false positive, false negative, and then false positives. That's how it goes. Now, better present on a visual. So, the question, which features help us most in predicting survival? To answer this, you go back to what? To which features, you come back to this. Maybe the first, these ones. The ones with their weight above 0.5. Yes, away from that, these ones are having their weight above 0.5, highly likely. Yeah, but the first is sex, followed by fair and this. And some of them are playing a negative role. They have an inverse. Now, this negative means they're comparing men against women. You get it?
But all of them have negative stuff.
No, understand something, yeah, not all.
Okay, fair does not have.
Negative means we are comparing with the first thing here, you're noting here, this coefficient here, it's like the weight, right? Or in normal, we'll say odds, right? Yes. So, women had a higher probability to survive than men. So, they have, because what you do is not like regression, you say a unit increase. Here they're comparing with another group. Which group has a high probability of survival? Or if you take which death, you will now compare. If you say which group has a high probability to die, men have a higher probability to die compared to women. So we must, when you are doing this, when it's binary, you are doing the comparison. You get the idea? So how do you want to? Gender was a factor. That one we accept. That's why it is a significant factor. But who had the higher probability of surviving or dying? That's the question. How do we know? You need to know whether they are comparing. Okay, let's go and do research. How do we know? How do you know? You take the value 0 and what was your value? 0 was what? 0 was what?
0 was survivor.
0 was survivor. No, for gender. What was 0? 0 was for female.
For female.
Yes.
Then 1.
Male was 1. So they're taking male now and comparing it with female. Right? And so the value is 0.12. I mean 1.24. Right? Send that, and it's negative. So it's negative, meaning that men were 1.2, or let's say 125% chances to die compared to women, because we're doing comparison with the death class, those who did not survive.
So now with this figure now, do you know if it's men or female?
I need to know your coding now. Your zeros and one, which one is? Because they pick the face value when they're doing now. Okay, again, comes back to when you are inputting, they pick the first value, and the first value in our model will be 0, not 1. You need to understand. There was a pick, they're comparing with the 0 class, and the 0 class here was gender. You get it? And it was female. So they will give you the, normally if it was using a software like JAPS, they will normally put, they will not put the sex here. What they will put here, they will put the female. I mean, they will put the male here. And they will not put male on this table. Right? So they will put male and they will not put female here. You know that they're taking this and comparing because they call it a reference group. If you are doing logistics, you know they will talk about reference group. If you have 5 categories, then they pick the first category. If, let's say, level of education, we have the first category is, okay, look at this one, embark. We have embark S here, embark pure. Where's C?
Well, we remove C.
We don't see. So whatever we're comparing here, we're comparing with the C group. That these people who are in the group S were less likely to die compared to those in what? Group C. Those in group Q were less likely to die compared to those in group C. So the class that is reserved is used for the comparison.
So H now, which H do you
H is a continuous variable, so we don't have a group.
So they are comparing the word because they still minus the
H here now says, since a continuous variable, it says as you increase, your chances of survival reduces. That's a negative this thing. That negative sign means inverse relationship between survivor and you get it? Yes, a continuous variable for categorical variable you compare. That's why most of when you do regression, if your variable is categorical, you must dissect it into different categories. Although most of the time we ignore in content of education, come and take all of that and put 1, 1, 2, this and just run. But the standard approach is that once your groups are categorical, you must put a reference group, right? You must have a reference group, and you pick now each group against the reference category. So, if let's say level of education we did not go to school as the group we are comparing, so those who are at the university level, how many times will they perform better compared to those who did not go to school? Those are high school, how many times? So that's like the odds of performing better. You get the idea?
yeah,
So there's always a reference group.
Using male and female.
Male and female. In this particular category, right? Male, female is our reference category.
Yeah.
So the value here, if we are using the principle of odds, the principle of odds says that values above 1, any item that has a value above 1 has high probability of surviving. Values below 1 have less probability. And if you go now, if we're using the probability, anything that is above 1, right? Anything that has a value above 1 is probability is 0.5 and above. Any value that is half its odd below 1 is probability is below 0.5. You get it? Yes. So items that their values are above 1, for instance, gender here, which we are saying this is male, and we are comparing male now with a female category, and the value is negative, it means that males have what? A lower, because why are they having a lower? Because it's negative chances of surviving compared to female. But if you reverse it to survive, men have what? Higher chances of dying. So negative sign shows you the direction with respect to the group you are comparing. Yes. So women normally, again, if you know from the data set that women had high probability of surviving that, and that age was inversely proportional to, yes, more older person died than the young. We are seeing that, right? Why? Because although it was more or less the young, the old were preferred and the young, but generally the data was populated more of the active adulthood. So again, it's to understand the concept. So what can improve our model? We can add more variables. The more variables you have, the better. But then it's not only about adding more variables, it's for us to be able to check variables that are playing a significant role. Because at times we have to drop some variables, which we will see in the future where we talk about feature engineering. With feature engineering, the idea behind the whole model is for us to remove the variables that are not doing well from our algorithm, or at times try to combine some. Yes, variables with where we have more collinearity problems we remove. Yes, so those are some issues, and as well variables that are not contributing much to there, and in some cases you have to combine other variables to bring up new variables. That's the concept of feature engineering, which I think we'll see later. So what happens if we use a different model? Right? Why do you think some people survive, why others didn't? Those are questions to reflect. But what is important here, if we're using a different model, decision tree, so in the next class, maybe we'll take on decision tree and random forest. Maybe we'll make, take them.
Same data set.
We can use the same data set to compare the accuracies, or use a different data set. But there is an exercise for you to do. I haven't understood this, so in the next model, you look for a data set, heart disease. There's a data set on heart disease, and implement logistic regression model. Report your findings. So we're saying your accuracy. Oh, let me not use metrics. Call them performance metrics. Performance metrics, accuracy, precision, recall, sensitivity, and the last one was what? Specificity. Then F1 score. I don't know how to spell score myself. F1 score. Is this the right spelling of score? Oh, you don't also know. Then present a confession matrix, and last but not the least, which features had greater influence on the model. So the name of the data set is heart disease. So you can learn how to retrieve the data set and use. You should be able to identify your targets and your features. You do that tomorrow. We have a class on Sunday. So you said class period tomorrow.
Okay, we use the class period to do it.
Yes. We have a class on Sunday.
So let's go on now and data set of practices.
Or use a different data set. Look for a different data set. Or look for any data set. That is categorical outcome variable. Must not be. Every previous order you have done. Give me a model there. Give me an example of one. Heart disease. That's a common. There's another one that you can still use. This thing. that we may.
I think my data set is shared with two houses.
We have.
Those who smoke, those who don't
There is
smoke.
also the iris data set. Iris. Let's talk about plants. Can also use that one. But I think that will it be good for? That one is good for. Yeah. But it's like has more than 2 categories classification. So it can be good for, might not be good for binary logistic regression. We'll likely use that one later on.
If they have disease, okay, you might go and look for another data that is not good for binary or.
But you are looking for data that's good
for
now.
logistic. How will you know?
But how will you not know?
Sorry, I still learning.
Logistic data set simply means you are dependent variable should have 2 categories. You are using binary logistic. That's all.
Yeah, this one that I'm talking about is kind of good categories.
Then that's all. It's good. Can you use it? We have the code, so once we have the code, that's on. This code will maintain.
Yeah.
Can be slight changes with respect to data.
Former smokers, current smokers, and those who don't smoke.
How many? That's 4.
No. We have current smokers, those who former smokers, and then those who do not smoke at all.
Then you can do.
So where do we see the assignment?
Mm?
Email.
Email.